Right, this is the 6th lecture on differential equations, and it's on solving second order differential equations with exponentials. Right, now first off you should remember a second order differential equation is where it has like d2y over dx squared plus dy over dx plus y equals 0. And to solve these, we first let y equals e to the lambda x, and so if we differentiate, we get y dash equals lambda e to the lambda x. Then we do it again, we get lambda squared times e to the lambda x. Then we substitute this into our equation, and generally all these e to the lambda x's will cancel, so it's basically just like substitution. If it has two double dashes, you substitute lambda squared. If it has one, you do lambda, and if it has none, then you just substitute the value 1. Right, then you solve it to get your value for lambdas, and then you put it into the form y equals a e to the lambda, then your value, so e to your value, so say you had your values for lambda as 4 and 5, you'd have a e to the 4x plus b e to the 5x, so you put your values in. And sometimes you may get double roots. If you have something like x squared equals 0, lambda squared equals 0, sorry, then you've got two values that go through the same point. You've got a lambda 0 and a lambda 0. So if it's a repeated root, then we have y equals a plus bx, all to the e to the lambda x. Right, now I think we've got an example. Oh, we have two examples, and I haven't split them up in my mind. Right, our first one. Y double prime plus 3y prime plus 2y equals 0. Now first of all, we want to put in our substitutions. Remember I said most of the time all the e to the lambda x's will cancel, so it's basically like substituting in the lambdas. So we have lambda squared plus 3 lambda plus 2 equals 0. Now we can solve this by factorising, and it goes lambda plus 1, lambda plus 2 equals 0. Perfectly fine. So with these we've got our values for lambda, which are minus 1 and minus 2. So then we can put use our general equation to have y equals a e to the minus 1 x plus b e to the minus 2x. Perfectly simple. Now we have another one here. We have y double prime plus y prime equals 0. So that goes into lambda squared plus lambda equals 0. You can divide through by lambda, so that goes lambda plus 1 equals 0. And then we can move 1 over, so we get lambda equals minus 1. Now we've only got one value, so that's perfectly fine. So we have y equals a e to the minus 1x. Do you have another example? Oh, we did somewhere. Nope. There we go. Right, this one's with a repeated root. So we have y double prime equals 0, which is lambda squared equals 0, which is fine. Now, lambda equals 0 is a repeated root, so we change the general solution because lambda equals 0. We change the general solution, so we have y equals a plus bx, all times e to the 0x, and e to the 0x is 1, so you could just put the general solution as y equals a plus bx.